Okay, so now that we've taken a look at the approach we'll need to use involving editable nodes so that we can match our IK handle to the end of the bone chain, let's now begin actually matching IK to FK. Now we can think of the FK to IK tool that we created back in Technical Rigging 3 really as a proof of concept or a prototype. It was really good for demonstrating some of the necessary concepts of understanding how an effective FK-IK setup works, but now we're setting up a very specific solution. We've got our twist working in a very specific way, and it's using the IK twist parameter, not a twist effector. We've also got those IK stretch parameters to take into account. So what we're going to do, we're going to have to approach this in a different way to the matching IK over to FK in Technical Rigging 3. But hopefully, for those of you who did follow along with Technical Rigging 3, you're going to see us approaching this problem in a slightly different way here, and that will give you a feel for two ways to approach a different problem. In this case, we know we're building something designed specifically for this rig that will exist inside an asset, and that's why I've taken the decisions of calling on certain functions and writing this in a very particular way. Now, it's actually going to break down into a number of videos. In this video, we're going to deal with solely matching the IK handle and matching our stretch parameters. Then over the next couple of videos, we're going to take a look at the slightly more complicated part of this matching, and that is the rotation on that twist control and getting that to match our FK. So in this video, we're going to be looking at getting the IK handle to the end of our bone chain and also looking at matching the stretch parameters. Now, it's worth mentioning this match IK to FK function has one particular scenario where it will fail to match our arm's FK, and that's if the elbow has been rotated back past the limits that our IK can have. We know that if I switch over, blend over to FK. Fantastic. We know that our arm can rotate around like such with our IK setup. However, because of our rest angles, it's impossible for IK to match that rotation. If it matches that rotation, what's actually going to happen is some of the bones, like the upper arm bone, will be rotated through 180 degrees. The only way we could match that rotation if the elbow has bent past its normal limit is if we were to change the rest angles of our bones. That's something that I do not want the tool to do. Changing the rest angles of the bones would be a very bad idea, because then we're going to have issues whereby now if we were to try and match to something over here, we need to change the rest angles again. Everything would become a huge mess. So it does have that one limitation. If our FK bones were bent back in such a way that the elbow is bent back past its normal limits, we cannot match the IK to that. Other than that, this arm IK the arm FK setup can be matched perfectly by our IK by using the tool that we're going to create over the next couple of videos. So the first thing I'd like to do is specify a position, a target position for our end effector. To do that, I'm going to wire a null off of our lower arm and specify that it moved down to the end of the lower arm. So let's jump over to our L_lower arm. I'm going to wire a new null off of that node, and let's call this L_arm_end effector target position. I want to go ahead and set its translate in Z to a negative L_lower arm / length. So we're going to travel down the length of the bone in the negative Z direction. That would take us down the length of the bone and position us at our target location for the end effector. Now that we have that, we can go ahead and create three new parameters. I will turn off the visibility and selectability of that node. We can create three new parameters over on our asset. So I'm going to bring up the type properties for our asset. And let's jump over to the parameters tab and create three new parameters. These will be operator paths. The first is going to be our IK handle, since we need to modify the parameters on our IK handle. And that's going to be any object null only. The second is going to be our editable IK handle, which, if you recall, that is the null that exists in the exact same space as our IK handle, but is going to be later when we set this up as a full asset. Again, that's going to be in Character Rigging 2 that we actually set this up as a full asset. We can specify that particular null as an editable object, as an editable node. That means that we can make any modifications we like to that particular node inside of a locked asset, and we're not going to get any permission errors thrown at us. So that's going to be our editable IK handle, and this also is going to be object null only. And then finally, we're going to have our IK handle target. So this will be our IK handle target. And again, this will be object null only. So again, that was our IK handle, our editable IK handle, and our IK handle target. With those in place, I'm going to go ahead and accept the type properties, and we can specify the various nodes for these. So our IK handle is, of course, our L_arm_IK handle. The editable IK handle is the L_arm_IK handle_editable. And the IK handle target is that newly created L_arm_end effector target position null. So with those specified, we can turn around, create a button for matching IK to FK, and begin by setting up the script that's going to match our end effector to the end of the FK bone chain, and also deal with setting the stretch parameters for IK on our bones. So let's bring up the type properties for our asset, jump over to the scripts tab, and I'm going to start out by defining a brand new function, and this is going to be match IK to FK. And let's start out simply by blocking in this function with comments. So the first thing I want to do is basically get the various nodes from our parameters. From there, I want to store the old FK/IK value and set ourselves over to FK so that we can reference the bones set up as if they were being driven 100% by FK. So set to FK, that is a value of 0. I then want to position the end effector at the end of the bone chain. And finally, I want to match the IK stretch parameters to the current FK stretch parameters. And of course, we do want to go ahead and restore that original FK/IK value. So with that in place, so that we don't end this particular function with a comment, I am going to print out match IK to FK temporarily. We can jump over to our parameters, jump and create a button. This will be our match IK to FK button. And I'm going to call, with the Python scripting language, who.pwd.hda_module.match_IK to FK. So if we accept that, and now click on the match IK to FK, we'll see that we are indeed getting printed out match IK to FK. If we clear that, we can click that again to verify match IK to FK is being printed out. Let me move that out of the way for now, bring back the type properties for our asset, and jump back over to scripts. Fantastic. So we want to go ahead and get the nodes from our parameters. So we're going to be getting the IK handle, the editable IK handle, and the IK handle target. So our IK handle is equal to who.pwd.node who.pwd.valPalm IK handle. The editable IK handle is equal to who.pwd.node who.pwd.valPalm editable IK handle. And then the IK handle target is equal to who.pwd.node who.pwd.valPalm IK handle target. So we're evaluating those three parameters we just created and turning those into node references so that now we have them as nodes, we can actually go ahead and work with them. And the first thing I want to do is obviously set ourselves over to FK, and that will cause our bones to be oriented in the view such that they are set up for the FK rotations. That allows us to then go in and reference the current position of the IK handle target, which we know is the end of the bone chain when we're set over to FK. So I'm going to say the old FK/IK is equal to who.pwd.valPalm FK/IK blend. And then I want to set who.pwd.palm FK/IK blend. Let's get the referenced parameter and set pending a value of 0. So we're going to go ahead and set that over to FK. If we accept this and we take a look, currently we're set to a value of 0. Let's set that over to a value of 1. If we click match IK to FK, and we can see that, and that has actually thrown an error. That error was that the palm object has no attribute get reference palm. That's because there's a D on the end there of reference which needs to be added. So let's go ahead and that's get reference palm. If we accept that, clear that out, Go ahead and match IK to FK. Fantastic. You can now see we're set to a value of 0. If we set that back to 1, match IK to FK, that gets set to a value of 0. So that is indeed working correctly. Let's bring back up our script and carry on working. So the next stage is to position our end effector at the end of the bone chain. To do that, I basically want to grab whatever the current transformations are in terms of translations of our target for the IK handle, and I can do that very easily by calling on a Python function that belongs to objects, and that is the world transform function. That will return to us a transformation matrix that positions an object in the world space location of the specified node. So that's not a local transformation, so that's not just referencing the transformation parameters. This is taking into account all of the parenting and the pre-transform of that node and getting the absolute world space location. So we can say that the target transforms are equal to the IK handle target dot world transform. So our target transforms are equal to that world transform. This is a matrix that is being returned to us. What I want to do is basically ignore everything except for the translations in that matrix, and to do that what I can do is call on who.hmath.buildTranslate. So I want to build a translation matrix, and what we can do is we simply pass in a vector. Here, if we pass in a vector containing our translation values, that will build a matrix, since later I want to set using a matrix, and to get the vector of those translation values I can call on target transforms.extract translates. So that's going to take the translates from our current transformation matrix, which also could have rotations in. It's going to extract those so we only have translates as a vector, then pass that to who.hmath.buildTranslate, which will build a new matrix, a translation matrix that now only has those translations in, and we can store that into target translate matrix. So set that equal to that matrix. Once we have that, we can now go ahead and set the world transform for a node. And this is a very, very powerful Python method because it allows us to take a world transform matrix and say, I want to set our node to have that world transform. That means Python and the Houdini object model is going to go away, and it's going to look at the current node that we want to set. It's going to look at its pre-transform if it has one. It's going to look at all of its parenting, and it's going to calculate the transformation parameters needed to give it a world space location that we are specifying. That means we don't need to worry about the pre-transform or the parenting on this node. We only need to worry about the world transform location that we want it to exist in, and then we can simply call on the set world transform method, pass in that matrix that we want to set it to, and it will take care of everything for us. So it's an incredibly powerful function. And now we're going to do that and apply that to the editable IK handle. Again, this is the function, the set world transform function, that's going to modify our parameters. If we do that on a non-editable node inside a locked asset, that will cause a permission error. We mentioned in the previous video that what we can do, we can have a hidden node that is editable, and as long as it exists in the exact same space as our actual IK handle, if we apply the set world transform method, passing in that translate matrix into that method onto our editable node, we can then copy the transformation parameters from that node over onto our actual IK handle. So I'm going to go ahead and say our editable IK handle dot set world transform, and I'm going to pass in that target translate matrix. So it's going to take in that translate matrix, and that's now going to have set our editable IK handle to have the position of the end of our bone chain. That means the translate X, Y, and Z parameters of that editable IK handle are now the exact parameters we need to set on our real IK handle. So I can say IK handle dot palm, the translate X parameter, and let's get the reference palm, since if we're inside a locked asset, we do indeed want to reference a parameter that we know this parameter on our IK handle is going to be one of our promoted parameters. It's a parameter the animator is going to be dealing with. So we want to get the reference palm, and I want to set that to a pending value of our editable IK handle dot eval palm translate X. So we're going to take the translate X of that editable IK handle, and we're now going to evaluate whatever that value is, set that as a pending value on whatever our translate X parameter on the real IK handle is referencing. So let's grab that entire line, paste that twice over, and we can now adapt that to translate Y and translate Z, both what we're evaluating and what we're setting. So we're going to reference all the translation parameters, and we're going to set those over onto our actual IK handle. So if I accept this, let's go ahead and let's set up our FK in a very interesting setup, something like this. We know that now if we click on match IK to FK, we should see our IK handle snap to the end of the FK bones, even if we're already set to IK. So let's say match IK to FK, and we can see that there we are, indeed, currently set to the end position of our bone chain. So that's working fantastically for us. I do want to go ahead, let's grab that guy, zero him back out. Let's also zero out the rotations on our FK controls, just to zero everybody back to their rest pose. And then we can bring back up our script and continue working. So the final thing I'd like to achieve in this video is to match the IK stretch parameters to the current FK stretch parameters. We know when we're dealing with matching the FK can only be stretched by those manual stretch parameters. We know if we have an end effector at the end of the FK bone chain and we set our IK stretch equal to the equivalent FK stretch, that our bones are going to exist in the exact same location. We know that because if the FK bones can reach there, then that means if our IK bones are long enough as well, they can reach there, and our automated stretch will not take over and will have no effect in that current setup. So we can simply copy the FK stretch parameter over into its corresponding IK stretch. So I'm going to go ahead and say who.pwd.palm, and I want to grab the upper IK stretch, and I want to get reference palm, and I want to set a pending value of who.pwd.eval.palm and grab the upper FK stretch. So we want to grab the upper FK stretch and apply that into our upper IK stretch. If we grab that entire line, Control C, paste that over, we can now repeat that for our lower. So grab our lower FK stretch and set that into our upper, so let's change that out, set that into our lower IK stretch. So we're taking whatever's in our manual FK, setting that into our manual IK, and that indeed will match the stretching for us. So let's go ahead, and to finish off this video, we can go ahead and restore that original FK IK value. So who.pwd.palm FK IK blend .get referenced palm, and we want to set pending our old FK IK value. And with that, if we accept that, we now should have both the stretchiness of our FK and the end effector matched. Obviously, we're not going to have the twist parameter matched yet, which means we may get some differences here, but that's fine. Let's go ahead and also jump over and let's give ourselves some upper FK stretch. And lower FK stretch currently does not seem to want to work successfully. Let's jump onto our lower arm. This could be something to do with a parameter reference for some reason not quite working correctly. So let's jump in. Let's see if lower FK stretch is indeed should be referenced correctly. Let's go ahead and see if we can cause that to update. And that's not wanting to update for a second. Let's see if that is working. If we blend over to IK, is the lower IK stretch working? There's the upper IK, there's the lower IK. If we now blend back over to FK, is the lower FK stretch working? And there we go. So for some reason we just had to force Houdini to actually want to update. Now it is updating. There we go. I don't quite know what was causing that. Some weird parameter referencing the way Houdini was cooking the network. But now we do have stretchiness on both of our bones. So if we match IK to FK, our end effector moves to the correct location. You'll notice those values get copied. If we blend over, almost identical. The only difference there is a very slight twist that is being caused, and we know that we're going to be able to fix that over the next couple of videos when we look at how we can actually get our twist to match. So I'm going to put these back to their default values, put our FK controls back to their default parameters, and let's do the same on our IK handle also. Fantastic. Let's make sure he is zeroed out as well, and he is. So now we have completed the beginnings of our match IK to FK. In the next video, we're going to talk about how we can approach getting that twist parameter to be calculated to match correctly, because that's actually quite an interesting part of the matching IK to FK, because we have a very specific setup here. So we're going to have to deal with some vectors and look at some vector maths and how we can work out angles between vectors and the like. So actually, I find that next section very, very interesting. But with that, that's going to conclude this video. Thanks a lot.